Number 1 asks us to convert this angle, 11 pi over 4, from radians to degrees. So to convert from radians to degrees, we're going to multiply this by 180 over pi. And you can see that when we do that, we're going to have a pi in the numerator and a pi in the denominator. Those are going to divide to 1, so we can just get rid of those pi's right now. 11 times 180 is, let's see, 1980. And then divide that by 4, that's going to equal 495 degrees. Which makes some sense because 11 pi over 4 is bigger than 2 pi. So it's more than one rotation. And 495 degrees also is bigger than 360 degrees, so it's more than one full rotation around the circle. All right. The next one, number 3, says that Dilshad Navarov of Tajikistan won his country's only medal in the 2016 Summer Olympics in Rio de Janeiro by placing first in the hammer throw with a throw of 78.68 meters. He spun the hammer around 6 3/4 times before releasing it on his gold medal winning throw. Express this rotation as an angle in degrees and radians. All right. Well, so if you're unfamiliar with the hammer throw, what happens is it's a big metal ball at the end of a chain that they spin around several times to get some momentum before finally releasing it, and it flies through the air. And so what Mr. Navarov did was he would, from the place that the ball started, he spun that ball around 6 3/4 times before releasing it. So if we can imagine, if this is our initial position of the ball, he took that ball and went around 3/4 of the way. So, so this would be the direction that he threw it. If it started here, he threw it going this way. And that's 270 degrees, right? 3/4 of 360 degrees, which would be all the way around the circle. But then he spun around another 6 times. So there's 1, 2, 3, 4, 5, 6, and ended up throwing it in this same direction as if he had just spun around 3/4 of one time. So each of these angles are going to be what we call coterminal angles. But what we want to know is what's this total angle? 6 3/4 rotations around. And to find that out, all we have to do is take that 6 3/4 rotations and multiply it by the number of degrees in a full rotation, which is 360. And so 6 3/4 times 360, if we plug that into our calculator, 6.75 times 360 is 2,430 degrees. And then to get that same thing in radians, just take our 6 3/4 times 2 pi. And so 6 times 2 pi would be 12 pi, and then 3/4 times 2 pi would be 3 pi over 2, or 1.5 pi. So this would be equal to 13.5 pi, or as we would more commonly write it, 27 pi over 2. So that's our radian measure, and this would be our degree measure.